Welcome to Speakeasy JS, the meetup for mad science, hacking, and experiments. I'm Faraz, and I'll be your host this afternoon. Mad science is about building things that make people say, I didn't know that was possible. So I'm super excited today to be joined by James Kyburz. Hey, James, how's it going?
Well, thanks. And yourself?
Pretty good. So you're joining us from Ireland right now, so it's like midnight there, isn't that right?
That's right.
Oh man, thanks for staying awake for us, and hopefully you don't fall asleep during your talk, but I don't think you will
Let's
because you
hope
got
so.
some really good stuff for us today. So James is going to be talking about his title is Attempting a Distributed Append-Only Log in a Serverless World. And for those of you who joined us at Speakeasy before, you know that we have a lot of talks about different distributed log structures. It's kind of a favorite topic of ours here. So I'm super excited to hear James's talk today. One other thing before we start. So if you're enjoying Speakeasy every week, please help us spread the word. And if you could go right now to your favorite social media site and share the link to the stream, that would help new people find Speakeasy because we're always looking for new mad scientists to recruit into our ranks. So with that, I'll turn over the stage to you, James. You can take it away.
Yeah, thanks very much. I'll just get some screen sharing. Do you see the slide okay?
Yep, looks good.
Brilliant. Okay, well, thanks for having me. So I'm going to talk about attempting a distributed append-only log in a serverless world. So to give you some background, a while back I was developing a site, a Nordic site, an e-commerce site where you basically purchase products. And early on, we needed to have like an affiliate sort of network where we were sort of importing products and having to categorize them. And we had a number of us that would be working on this. So it was decided early on that we wanted some form of not just accountability, but full insight into all the state changes that happened over time. So I'd worked with a number of sort of projects where I'd sort of built logs in the past, rather than using an approach where you just manipulate state in time. So I was heavily inspired by sort of event sourcing, where you have this concept of, rather than changing the state, you build up a log of small events, and you can aggregate over this log to build whatever you want to build. Like you can do your CRUD for if you want to like represent a user or something like that. But you can also, from the same log, build other things like Elasticsearch and various different databases. So I started off building this thing, which I called Level Event Store. It's been in production for a while, and it's hasn't got so much love recently, but it's still there. And things went well. I built the stack using sort of Docker and a monorepo, and that's where I got started. So how things went. So I would say that things did go well. They went as planned, where we built this thing where it was sort of the center of the entire stack, and we got full insight to all the state changes that happened over time, and we could build multiple projections. Projection is like, it can be anything from a read database to Elasticsearch to things that you just need on the fly. Things that didn't go so well, not so much didn't really go well, but the actual design of Level Event Store was a single running node process, which maintained all the sequence number of the logs, which basically meant you can't scale it. So some of the things that I learned sort of early on when building something which reacted to events was all the event handlers that reacted to these things had to be as deterministic as possible. Idempotency was important. Any external factors basically meant if you wanted to replay the events again, things just failed badly. So it's basically how to not shoot yourself in the foot. So and rather than when you run into issues like in a sort of a traditional database, you find a bug, and maybe the bug has to do with state, so you just manipulate the state accordingly. If you're building an event based architecture, then you would fix this by creating a new event. And just to give you sort of an idea of when this was 4 years ago, which of course in JavaScript that means like 28 years ago. And what happened after that was I caught the serverless bug, as I call it. So at the time I was just intrigued and started sort of playing around with serverless, just sort of seeing what it could do. I'd already built sort of the backbone of this stack, as I said, using Docker containers. So to give me some time, I wrote a little tool. As all our services were very small, I wrote a tool that allowed us to basically take something that was previously running in Docker and it could just run in Lambda instead. And that's what I did. And to sort of categorize the things that sort of what serverless meant to me was less time sort of thinking about the DevOps and all the scripts to get things provisioned, Terraform, and didn't need to care about security patching anymore. And then you'll hear sort of when the topic's mentioned, people always mention price. For what we were doing, things were definitely cheaper, but obviously everything's relative. I think the main power of it is the blast radius of when things break, when things fail. So rather than an entire service going down and people actually realizing this, you just get functions that fail. And it also gives you an insight to when things do cost money, exactly why. So on a functional level, which is quite addictive when you get into that. And at the time, I also built a tool to allow to make it possible to interactively debug processes in Lambda. I'd built it previously for Docker containers, but the tool has nothing to do with just Lambda. It allows you to debug a process that you don't have any SSH access to. So check it out if you're interested. So the talk. Basically, the talk is taking this function, which was the backbone of the event store, and making it run in serverless. Now, you don't need to pay too much attention to exactly what this does, because I'm going to say. So what it does is it's an HTTP call for every event that you want to register, and it basically writes this into level DB with appending a sequence number, incrementing it. And that's pretty much all it does. There are other things that are happening, but this is where the magic starts. Well, not really, because I gave up quite early on when I had initially the plan was to port level event store in its whole to run in serverless, and I gave up because so many things just didn't fit. So it's still very much a work in progress, but I'm having fun doing it. And as yet, I'm not actually running it in production, but so here goes. So the design decisions of where I started is pretty much where I am now. I decided to use DynamoDB early on. I'd had some previous experience using it, and it was pretty much free the first year, probably because we didn't have enough traffic in our site. But I liked it, and I stuck with it. And the reason I chose it was that there are a number of things that you can build on top of DynamoDB. It has this interesting characteristic of streams where you can. It's very much like CouchDB's change stream, or Rethink, where you can actually sort of subscribe to changes as they occur. But being in serverless, it creates a trigger for a Lambda function. So you can basically listen to these changes. And if you're interested in learning more about DynamoDB, then check out the brilliant book by Alex Debris. It's a definitely good starting point, or even if you've been using it, it's a good book anyway. So I mentioned a few things just didn't fit. One of the things that I had for reacting to the events was these long-running processes in Docker containers, basically polling with WebSockets, and that just wouldn't work. And then various sort of aspects of how the querying mechanisms worked. I decided let's just get rid of it because it didn't fit very well with DynamoDB. So the current design and where we're at is a single DynamoDB table for all the logs, and using this concept of numerical sort keys. In Dynamo, you have a partition key and you have an optional sort key. So I'll get into why I chose numerical sort keys, because I did actually experiment using UUID, which is like a universally lexicographically sortable identifier. So it's like the UUID, but it's actually sortable. But what that means is that you can't, because it's not deterministic, you can't check if something already exists. So you can't check for immutability, which is why I sort of opted out. And then DynamoDB streams is something that you can just configure your table to use, which means then you have the ability to send all the changes to a Lambda function. And then we'll be using EventBridge. Now, EventBridge is something, it's like a managed event bus, so you can subscribe to all the changes that happen over time, and then you can connect Lambdas to that as well. So it's Lambdas all the way. So as I said, you write to DynamoDB, it gets picked up by the stream, it sends it to a trigger, which is a Lambda function, and all this Lambda function does is it sends it on to EventBridge, and then it's up to EventBridge to send it to all the targets. So in this repository, what you'll see is there's just a single Lambda listening to these events, building up state in another DynamoDB table, but you'll see it in a bit. So what you get is a time-ordered sequence of events that are on a key level, and this data is held for 24 hours. Which, if your function is doing something simple like ours is, just basically sending it onto EventBridge, 24 hours is fine. It really shouldn't fail that much, if at all. And here's the example of what it looks like to actually create an item in the log. So we have a partition key and sort key, which are the PK and SK. And then we have the type of event. So that could be, in the examples, you'll see like sign up or add telephone number. If we're talking about a user, all I have is users, so I'm sorry. I could have picked a proper example, but that's all I've got. And this is showing the conditional expression where we make sure that it's immutable. So we're making sure that we're not writing over ourselves. And then EventBridge, this is what it looks like, just sending the data to EventBridge. I decided to add the example there where it's not actually possible to send the entire payload that comes in Dynamo because of constraints. We'll get into that in a bit. And this is what it would look like if you have a Lambda target listening to an event, picking it up. So you would get exactly, here you can see the detail and the log type and the ID. It's basically exactly what you get here. So just to recap what we've got here. For me, I would say the first challenge with serverless is getting everything up and running locally, because it's great having the ability to deploy these things, but I find the necessity of running things locally a must. And so I'm using the serverless framework, and these are the plugins that I'm using to basically mimic the behavior locally. So we have everything from DynamoDB, our Lambda functions, the streams, and Eventbridge. And conditional functions is the ability to have a function that only runs locally. So when you actually deploy the stack, it doesn't get deployed. And then I also use a brilliant tool from the Marthem tech team, which allows you to. It's basically a CLI on top of Eventbridge, which I use. One of those things that doesn't exist locally is archive. Now, archive is needed if we want the ability to replay. And one of the sort of selling points in event sourcing is the ability to replay your events. So you can do anything from get back to a particular state and time to replay to see why something's happened. And yeah, it's good fun. So this doesn't exist. It only exists in AWS. But in order to have an archive locally, all you need to do is basically create an event handler that listens to Eventbridge. And in this case, it just writes the events as is to SQLite. SQLite, because it's just so simple. It's just one file. So if we just have a look at an example of what it looks like to run this, there's a tool, a script that I've written, which runs Docker, which you can basically perform all these operations. So if we start the stack using Node, it creates a DynamoDB table in memory. And here you can see that it's created 3 functions on the left there. The save to local DB is the archiving function. Otherwise, you have the event handler, which listens to the events that the trigger has posted to Eventbridge. And the trigger is the Lambda function that listens to the DynamoDB stream. So if we just query the table, it's empty. There's nothing there. So if we just create some fake users, so what this will do is it will uses the brilliant library Faker, and it will create 4 events for each user. I think it's sign up, add telephone number, verify telephone number, and add location. Think of it like a service where you're going to order food, because I couldn't think of a better example. Right, it's going pretty wild on the left-hand side there because it's archiving and it's picked up all the events. So if we have a look now at the logs, here we can see that we have a sort key, which is numerical, so it's 1 to 4. Yeah, they sort of come in a bit of a random order, but there you go. And I have another table, which is our read model, as an example, which will take these 4 events and build up a state on a user. So here's a complete user where you have the verified phone number and the location. Yep, and there we have. Now, if I kick myself out from the stack, but I don't delete the archive, I should be able to show you how replay works. So again, I will start the stack, and we have an empty database or empty table. Yep, nothing there. So here I can run the archive functionality, and because my event handler requires this it reads from DynamoDB, I have to write them to DynamoDB. Otherwise, I have the ability to just send it straight to Eventbridge. So we only have 1 log as an example, and we only have 4 events. So we'll just send that. And now we should be able to see if the users are picked up. And here we have them, yes. So all good. And now that everything's in Dynamo, we should be able to run the replay again, just to show you that we can run it to Eventbridge as well. Yep. So to configure the functions using the serverless framework, we define the patterns on Eventbridge, what we actually want to listen to. So everything in this repository uses DynamoDB log and stream changes, but then the detail would consist of which log, like users, and also the types, if you're only interested in a particular type or all types. You can think of it as a filter. So in the example, we only have one event handler, but you could have multiple. And then we also have the trigger function, which listens to the DynamoDB stream. So just to recap the table design, as mentioned earlier, the partition key is a string, and the sort key is numeric, and then the stream actually captures all changes. You can actually, for example, have just keys, but in our case, we want the ability to send everything that's happening to Eventbridge. And then the read model example uses a partition key and sort key as a string. And if you want to follow the sort of the single table design of DynamoDB, that's a good starting point, because it's much more flexible than my numeric sort key. So sort of some access patterns before we move on. If you're building this log of events, maybe you want to either build a read model or like a projection, like I mentioned Elasticsearch earlier. That would be a possibility, or building one or many read models. And if you're doing that, then you would typically have like a concurrency limit of 1 or some form of queue, because you wouldn't want to do things in parallel. And you can always query DynamoDB for a particular partition key to get where you're at. And as mentioned earlier, you want them to be idempotent. And then you also can have the ability to fire and forget. So maybe you have a function that just listens to a particular event, and maybe, as an example with the users, for all sign-up users, sends an SMS or whatever. And then also you could have none of the above. You could, if the events list are created in DynamoDB, even though they've been sent to Eventbridge, you could query a particular user by key and build up the state on the fly, if that's what you wanted to do. With event sourcing, that's when you get into sort of snapshotting and whatnot, if there are like crazy number of events, because that's quite cumbersome to read so much data. Constraints. I don't want to go into all of these constraints because it's a bit boring, but the two that I'm going to mention are to do with sizes. So DynamoDB has 400 kilobyte maximum size limit, and Eventbridge has less, which means that you need to be aware of it. But if you're building sort of a typically sort of architected event sourcing solution, then well, your event shouldn't be gigantic. You should be creating small events. And then the capacity units, I suppose I mentioned them as well. They're in the slide. So Dynamo has this concept of capacity units where you have these sort of like limits for reads and writes, and they are for a particular partition key. So one of the things Level Event Store did was it wrote everything for a particular log, like in our example, users, using the same key. That would be a really bad idea in Dynamo, because that would mean that these limits would apply for the entire log. So you want to sort of like split up your keys. So these things, these sort of designed constraints do change the sort of the design of the implementation. And then, as I mentioned, Eventbridge has its size limit is not 400; it's less. And just to mention that there are limits on how many buses you can have and how many rules. But I think if you ask AWS, they just say, like, you just have multiple accounts for everything. So, but they're good to know. What you get is sort of out of the box with this stack is quite a lot of sort of retry functionality. So typically you don't need to so much care about the before invocation things here, because EventBridge will retry for up to 24 hours, but that's only if like your functions like throttling, which happens very infrequently. What's more important is when your function fails. If it fails 3 times, it's going to never be called a fourth, but it will actually be called 3 times if the first 2 fail. And if you want to react to failure, then it's just a case of opting in for destinations. So you can like build lambdas that get called when other lambdas fail, and it's just lambdas all the way down. So this is all fine and dandy, but if we can't actually get this running in a proper environment, then it's not really anything of use. So if we prepare for just actually showing it in the proper sort of AWS environment, the first thing that I always get wrong is the IAM policies. So I use this tool called IAM Live, which rather than just wildcarding everything, gives me an idea of what the actual resources I need, what policies I need. So how it works is it uses something called the client-side monitoring in AWS SDK. And if you enable that, then basically everything you do gets sent to a UDP port, and you can listen to it. So I did mention the wildcard thing. It doesn't actually tell you what resources have been asked for, but it tells you what actions. So it's definitely a good starting point. So if I just start the stack there, then it creates the table, and it does some other things there with the DynamoDB stream. Cool. Okay, so let's actually get this running. Let's deploy it. So you can't see my access keys. They're of no use anymore anyway. Don't worry, it's going to go quick. So I mentioned earlier about the conditional function. So we've deployed 2 functions, the trigger and the event handler example. And this also creates the event bus, the event archive, and everything that's needed in the DynamoDB tables. So if we just query the actual tables in AWS, then we can see that they're empty. And if we create some fake users in these tables, so let's see, 51 users. And we'll just see, check the logs. There they are. And check the core table as well. Version 4, yep, they're all there. Brilliant. So what we're going to do now is a bit more crazy. So the fact that you have this archive in AWS, you can replay all the events just in AWS. But let's say you want to build a state of all the events that are in a production environment, or in this case, not production, to build the state locally. How would you do that? So heavily inspired by the Marthem tech team, I built something which basically uses a WebSocket connection. and then it sends, when you run replay, it sends everything through back to the WebSocket connection using just an ordinary event bridge target. So if we run that, okay, I think I didn't wait long enough because that's not enough events. So let's just see. Excuse me 1 second. Just having a look to see. Yeah, we have, the version should be 4 on all these users. So I think yeah, so it's nothing to do with the local handling. It's just the fact that the events weren't there. So I think we'll run it again. I should have waited a bit longer. Eventually consistent, right? Right, 204 events is the right number. So now if we have a look, yes, there they are. So to sort of finish up here, known issues. Well, ordering is apparently very hard still. My replay function replays as is, which it doesn't do anything with making sure that the order is correct. It just uses the replay that comes from AWS. So it means that if you're aware of the fact that that it comes in a bit of a crazy order, because I think it runs threads, and it like takes the window that you select and then runs a minute at a time. As long as you handle that in your event handlers, then it's the same thing as running a replay as is in a production environment. So I think it's a good thing. And this repository hopefully is a good starting point. It's maybe not ready for production, but it's heavily, all the heavy lifting is done by Dynamo and all the underlying sort of services. So it's not there's not actually that much code. It's probably more script than JavaScript. And then there are a few things that are missing in the offline implementation. So one of the things is the input transformation support, which now sort of allows you on your functions to take the actual payload that comes from the event, and you can select a field, or you can basically remap it to other fields. So that's missing, but you can just send pull requests to the brilliant plugin there. And just a quick note on billing. This has been sort of in production. It's been in AWS for a few months. I've sent thousands of things to it, and it so far hasn't cost anything. But don't take my word for it. If you're adding your own credit card, then you need to set up billing alerts. But that's pretty much all I got. So thanks very much.
Nice. Thanks a lot, James. That was amazing. So now it's time for questions. So if anybody has a question for James, please post it in the chat, and we'll go ahead and ask him. But yeah, in the meantime, I just wanted to say, yeah, thanks for sharing that. The slides were beautiful. There was somebody also commenting that in the chat as well. It's a little bit off topic, but do you mind telling us how you made the slides?
Yeah, sure. I mean, really, it's thanks to Chalk and Boxen. It's basically just JavaScript, just using template functions, nothing else. And then I must confess that when I ran the examples, then I used ASCII Cinema, because I was too afraid to see what would happen when I was live coding. I'd probably get some crazy thing going wrong. So which I did, but I kept it in at the end anyway.
Oh, that was actually not you live. I thought you switched to live, and that's why the mistake happened.
Yeah, no, I kept it in there because I wanted it to be real, because that is actually what happened. That I sort of added all these fake users and like ran the replay like immediately, and then it was like, oh, what happened there? So it gave me some
Wow.
insight too.
Wow, that's a great way to like fake a demo, is like to have a mistake in it so no one will suspect it.
Yeah. until you say it yourself.
Exactly, you can't just confess right afterwards. That's funny. So I was wondering if you could tell us a bit about the like, I don't know if you can talk about it, but the project you built this for, like how is this how did this idea come about, and like what exactly were you like? Is there a system you were trying to replace and use this instead of? Was it
So
that
the initial level event store. So that was a Nordic e-commerce site that was built sort of 4 years ago, and my company was sort of like very sort of into event sourcing, and there were a number of tools at the time, and I just looked at all of them, and they were too sort of like, they had these crazily sort of big APIs, and all I thought was, well, to sort of like build a system which is log based, all you need is a log. So I chose level DB, I think level logs from Matthias Boos, and something from Substack was in there as well, with the making sure that the locking worked. I mean, the problem that it was solving was just the fact that we knew early on that we were going to have multiple databases for various different parts of the system, and it was a good way to sort of tackle that problem. And we also knew that a lot of these affiliate networks with products, they're horrible. We just had to create so many rules to categorize all the products. So it was good to have sort of a log of all these things.
I see. So there was nothing off the shelf you could basically reach for. So you just like invented your own thing.
Well, yeah. Well, there were things off the shelf, but I didn't like them.
Yeah, exactly. So nothing that met all of your stringent requirements. So when you mentioned projection, I feel like I've heard that term before, but I'm forgetting. Is that basically the idea that you like? Actually, maybe you could explain what that was for us.
Yeah, so it's taking this sort of list of logs and building a state from that. And because like if I think in my talk I mentioned Elasticsearch, and then the other example was like another Dynamo DB table. So the projection would be in this case the state of the user in the Dynamo DB table, or the state in Elastic.
So is that cached, or do you have to read the full log every time you want to do a projection and build up that user state?
What it does is it actually it stores the sort from the sort key. It stores that in the read model. So every time you get a new event, it knows, oh, I only need to read from a given position.
Okay.
And then the other way of doing it would be if you don't have a projection at all, you just want to read the whole log. Then yeah, that's I think I mentioned snapshots and whatnot, because then it can get slow pretty fast if you've got lots of events.
Right. So when you have like say you have a user state, and then an event comes in for a different user. Does every state like run to see if that event may be relevant to it, or is it somehow smart enough to like only rebuild the state, like to do that projection process only for the affected user?
It would only do it for the affected user, yeah. So I mean, this is just an example in this repo, but yeah. So the event would be sent with like sign up or any event for the user, and then it would contain the key, and then it would send the event into Event Bridge, and then the Lambda that would pick this up would have the key. So it would basically just say, okay, I just need to build the state for this particular user.
And it like starts with the. Oh, go ahead.
Yeah. No. Sorry.
Oh, so does it like start with the current state that it has so far, and then you said it like knows where it knows the last event it read, and then it kind of just like goes up to the current one and updates anything that needs to be changed?
Exactly. And I must say that I've been a bit lazy there, because one of the problems is that if a lot of the events sort of happen really quickly, which in a normal sort of, like with a user, you'd like, you'd click, you'd like add your telephone number, you do this, you wouldn't like be doing everything random like a robot. But then when you do replay, these things can happen like milliseconds apart or at the same time. So you do need to sort of think, okay, I do want replay to work. So what I actually do in my example is, it doesn't matter what you send it for. The event contains the key of the user. That's the petition key, and then I just read directly from Dynamo to see, do I need to do anything? Where am I in the state? Which means that maybe the first time, if you have 4 events, but they're already in Dynamo, the very first time that the function gets called, it will build the state immediately for all 4 events. It does it as quick as possible.
Mm-hmm.
But you can do this so many different ways. It's hard to find. And I also thought, well, you could build like a lightweight sort of framework for doing this. And I thought, no, bad idea, because it's very project centric what you actually want to do.
Mm-hmm. So what's left to make it production ready? I mean, is it just that you haven't had a chance to use it yet, or are there more things you need to do?
Pretty much, I'd say that's the biggest sort of. I haven't actually. The actual site was. It actually got sold a few weeks ago and actually disappeared. It's still there using what I built, but. So that's funny. So if you go on that, it's a Swedish site. So, yeah. So I haven't actually got a new project that needs it yet. But I'm sure one will arise in one of my assignments and say, "Oh, I've already built this." Yeah. What otherwise, other than actually using it, I think. Maybe more benchmarking and basically more sort of testing to see how fault tolerant it is.
Mm-hmm.
As you saw I mean, these things are hard. Like if you have you have DynamoDB's stream saying, I give you everything in the exact order that it's written, and then EventBridge that says, I don't guarantee order. You have to deal with it.
So I see on the clock behind you that it's getting late there. So I think we might want to wrap it up.
That's confusing, because that's actually an hour ahead of what it actually is. It's because I do work with Sweden, so that's actually Swedish time. So I'm actually an hour before that.
Okay, got it.
Confuses everyone. I thought maybe I should take it down for tonight.
It's still almost 1 a.m. there, so yep. I think we'll probably wrap up now. But thanks so much for sharing that with us, James. And so everyone, James has agreed to do the social happy hour that we usually do, even though it's going to be super late for him. So I'll explain now how that works. So we are going to go to the URL that you see on the screen now, and you'll be able to get matched randomly to other attendees for a 5-minute chat. And the speakers will also be, so James will also be there in the chat, and so you'll be able to ask him your questions if you get matched with him. So yeah, we'll just go to that URL right here as we finish up. But yeah, thanks again, James. I appreciate you sharing that with us.
Oh, thanks for having me.
Yeah, of course. Yeah, it was really interesting. Cool. So everybody, we'll go over there now, and we'll hang out and chat and socialize.